Okay, so, sorry, I didn't catch what you guys said. So we took the left side, we changed it to xv prime plus v. We're substituting the right-hand side, so what can we do with this? X squared, and x squared, right? They all cancel out, exactly. So we're just going to be left with 4 plus 3v squared all over 2v. Just like that. Okay? All right, any suggestion on what we might want to do next?
Subtract the v.
Subtract the v over, okay? I like, yeah, these homogeneous equations always become what? Separable, right? And if they're separable, then that means we need to basically try and get all of the v's on one side. So what Lewis is suggesting, I think, is a great idea. The other thing I might do while I'm at it is change v prime to dv dx. So because we want to get all of the v's together, let's just subtract it over to the other side. Okay. So we just get that. And now, while I'm erasing the board, maybe you guys can try to simplify the right-hand side. It's just a little bit of algebra there to simplify that, and then we'll see where we're at. Okay. I was in Phoenix, and it was like 100 degrees, so I was cold the whole time. I came back. I mean, I was hot the whole time, so I had this heavy coat, and then I came back and I was freezing. So now I'm warmed up again. Okay, so how can we simplify the right-hand side? Anybody get any algebra done on that? Yeah, you're subtracting, whenever you're doing addition or subtraction and fractions are involved, you definitely need to get a common denominator. So the common denominator would just be 2v for the whole thing. And then the first part of it is just 4 plus v squared. And then the subtractive part would be minus 2v squared. Right? Which, that can be simplified, right? Because on top I have 3v squared minus 2v squared. So this just becomes 4 plus v squared all over 2v. And that's equal to x dv over dx. So we should be able to get it separated now. What I would want to do to separate this at this point would be, I'm going to take the dx and the x and flip them to the other side. And then this part has to go underneath the dv, right? So just in case it's not clear, let me put the x dv dx right there as well. So I have to move the x stuff to the other side, the dx over x to the right side. And then the dv is already on top on the left side. And I have to move this whole fraction here underneath the dv. But if I'm moving it underneath, it's like flipping it over, right? So I'm going to flip it to 2v over 4 plus v squared. There we go. Now we are in pretty good shape. Right? The idea is it is separated. Once we get it separated, we just have to integrate both sides. So on the right-hand side, of course, we're going to get the ln of absolute value of x plus c. You guys should be able to do integrals of this difficulty for sure for the test. This is just really 1 over u du, right? So it's just a substitution, u substitution. So the integral of 1 over u du would be the ln of u, but the u has to be replaced back in terms. So I didn't even write it down. I hope I'm okay. Didn't go too fast there. The u got changed back to 4 plus v squared before Amy got a chance to write it down. Okay. So, and notice I didn't even bother to put absolute value bars here because 4 plus v squared is always positive anyway. So I just leave it like that. And you don't need to put the plus c on both sides of the equation. You can just put it on one side and it'll be just fine. Okay. Is this a good final answer? Definitely not, because make sure you change the v back to y again. A few people forgot to do that on the quiz. So the v changes back to y squared over x squared equals ln of absolute value of x plus c. if I ask you for an explicit solution, which is the way I phrased it on the quiz, I didn't phrase it this way here, I just said solve it. But if I ask you for an explicit solution, explicit means I have to have y equals. I have to have it solved for y. Sometimes you can't get an explicit solution for a differential equation, and you have to settle for something that is implicit, where the curve is not solved for y. This one we can solve for y. Because what could I do with this equation from here? Exactly. I would exponentiate both sides. That would get rid of the ln on the left side. And on the right-hand side, it would give me e to the ln of absolute x plus c. E to the ln of x is just x, right? And there's an absolute value on that. And e to the c is just another constant. And please change the constant. There were a couple people on the quiz who they had like an e to the c and then you just changed it to c. But it's not necessarily the same number anymore. So I'll call it c1 times the absolute value of x. Okay? Remember, this is just e to like two things added together. So we're using this property that says e to the alpha plus beta is just e to the alpha times e to the beta. Right? So e to the first part is just absolute x. E to the second part is just a new constant, which I'm calling c1. Okay, now I need to subtract 4 from both sides. So y squared over x squared would be c1 absolute x minus 4. Now I have to multiply through by x squared to clear the denominator there. Okay, and use parentheses to keep your expressions simple here. All right, and then finally I could take a square root of both sides. So this would just give me, well, it's going to be plus or minus x times the square root of c1, absolute value of x minus 4. It'll look like that. Does it seem okay to everybody? Yeah, so that would be a reasonable explicit solution. So this is explicit. If I asked you for an implicit solution, we could have just stopped here. This is implicit. But usually, if it's possible to come up with an explicit one without too much stress, I usually like to try and get an explicit solution. It's better that way. So. Everybody good with that? Now here's the amazing thing. If you go back and you reread what this question says in the review session questions that I posted, it says, solve this differential equation by 2 different methods. I would never ask that on a test because it's ridiculous to play those kind of games on an actual midterm. But for a review session, it can be very instructive. So we solved this by one method, which was we recognized it as a homogeneous differential equation, and we went through the process, kind of reviewed it. Does anybody see another idea for how we could have solved this differential equation? Take it? Bernoulli. Did you notice how I kind of slipped right past that one? I said it's definitely not separable, or it's definitely not linear. And then Deshaun says, oh, it looks homogeneous, so we jumped straight to that, but we never addressed the fact that it could be Bernoulli. Sometimes these equations are more than one type. Doesn't happen that often, and I generally don't like to ask those kind of questions on the test because I'm usually trying to test one type in particular. But here, I claim this is actually also Bernoulli. Now, it might not be obvious to you. So how do you recognize more easily, let me change this to a y prime again. How do you recognize more easily that it's also Bernoulli? Yeah, you see the y squared here, so power of y on the right-hand side of the equation. But of course, remember, you do have to divide by this 2xy here. So I'm going to go ahead and erase this part of the solution. So does dividing by 2xy cause us a problem with that? So what can I do? Yeah, if you split this fraction up, it's going to make it more obvious what I'm talking about. So like the first part, 4x squared over 2xy, the 4 and the 2 makes 2. And the x squared over x is just an x, and then there's a y on the bottom there. And then for the second term, you have a 3 on top, and there's a y squared. One of those y's gets canceled, and there's a 2 on the bottom with an x on the bottom. So this is y prime can be written as that. Now, is that the right form for a Bernoulli equation? This is on one of your flashcards that's going under your pillow at night for the next 3 nights, right? So y prime plus p of xy equals q of x times y to the n. So I need it in this form. You really want to rewrite it so it matches the form. Yeah, so this term here really should be on the left side, right? So y prime minus 3/2 y over x equals 2x. Let me write this fraction of 1 over y as y to the minus 1, just to emphasize the form. Now, is that looking pretty good, guys? Yeah, that's the Bernoulli form that we learned. So we have now recognized that the same differential equation that was homogeneous is also Bernoulli. Okay? It's Bernoulli, and what is the n value here? N is this power, -1. So I always like to write off the bat, I like to write down the change of variables. So u is, remember the formula? It's also on one of your other flashcards.
1 minus y to be 1 minus n.
Y to the 1 minus n, which in this case would give us y squared. So u is equal to y squared. It just means that, this means that y is going to be plus or minus the square root of u. Well, that kind of looks good in terms of what we think the answer is going to have, is like a plus or minus the square root of something. So we're hoping to get the same answer, I hope. Otherwise something is wrong. Okay, is everybody with me on that step? Okay, good. So then we have to write down the new differential equation that we get after we change the variables. So it goes like this. We take u prime plus 1 minus n, which is just 2, remember. 1 minus n is 2. It is so important to get that right. You have to get the right number there. So it's a 2. Here is what was the p of x, right? 3 over 2x was the original p of x, but now I've got to multiply it by 2. So it's going to become minus 3 over x times u. So the original p of x of the original problem here, the Bernoulli form of it, was 3 over 2x with a minus. But now I have to multiply by 1 minus n. And that changes it to 3 over x. This is like my new p of x. Negative 3 over x. And then on the right-hand side of the equation, we also have to multiply through by 2. So this is the q of x that we originally had, 2x, but I have to double that to 4x. And on the right-hand side of this equation, we don't put any unknown function now. So this one has become linear. This is now a linear equation. This is clear enough? Okay, so now is where we get to use, we're reviewing a lot of things with one problem here. So now we have a linear equation. What do we need to be thinking about when we're solving a linear equation? Right, the integrating factor. So that's another one of the formulas that was in that list. It's e to the integral of p of x dx. And please, please, please be sure you include that minus sign. If there's a minus sign, it has to be included in there. Okay. What is the integral of 3 over x? No. Negative 3 ln of x, right? Technically it's absolute value of x. Let's assume x is positive. Just take that as an assumption. I'll tell you if you can do that on a test question. So we'll just leave it as is there. And now we'd like to cancel the e and the ln, but I can't do it until I get this negative 3 pulled up as an exponent. So this becomes x to the minus 3. you see why it is so incredibly important to remember to put the minus sign in there? If you didn't do that, you would have said the integrating factor is x cubed, and that would be like totally the wrong formula. So this is what you need there. Okay? So then, what we do is we multiply this differential equation here, the original u differential equation. We multiply this by the integrating factor, and what happens is you get a perfect product rule on the left side. So it turns out to be the derivative of the product of the integrating factor times the unknown function that you are currently working with. Okay? And then that equals, on the other side of the equation, you have your q of x here multiplied by the integrating factor. Well, that's just going to become 4 over x squared. Right? 4 over x squared. Okay, I'm going to come back over here because I want to save the answer from the first way we solved the problem to make sure we get the same answer again. I don't need much more time to finish solving this. Basically, now I just have to integrate both sides. When I integrate on the left side, I basically just lose my derivative. Okay? So x to the minus 3 times u. And what is the antiderivative of 4 over x squared? If you prefer, you can think of that as 4 times x to the negative 2. What is that going to give me?
Negative 4 over x?
Right. Basically, it's the power rule backwards on this. By the way, there is a certain contingent of students, not necessarily in my classes, but just in general in math, in calculus, who believe that any time you have a variable underneath a fraction, it automatically becomes an ln. That's only true for x to the first power being underneath the fraction. So in this case, this is what we're going to end up getting, because the 4x to the negative 2, if we just do the power rule backwards, it becomes 4 times x to the negative 1 over negative 1. Now, what else do I need to include over here? Right, there's a constant here. Remember, and I should have emphasized it again here, when we did the integrating factor, I didn't have to put a plus c on this piece of it. You never need to use an integrating factor, or you never need to use a constant, I'm sorry, when you're finding the integrating factor, because there are lots of integrating factors that work. Any one of these would work. You could choose c to be any number that you like. So if you just simply choose it to be 0, then you don't have to ever think about it. So that's always a good idea. Okay, so this is pretty good. Now we just need to solve it out. So I'm going to multiply through by x cubed. So if I multiply through by x cubed, I'm just going to get this. Let me simplify that. That's going to be cx cubed minus 4x squared. Alright, and that's what u is. And we said earlier, I always like to have it up here ahead of time, that y is just plus or minus the square root of that. So y is plus or minus the square root of cx cubed minus 4x squared. And if you pull out x squared from the radical, you have an x squared and x squared. If you factor the x squared and then pull it out of the radical, it just becomes x, right? Really, it's the square root of x squared. So that's basically just x. And then what's left is just the square root of c times x minus 4. Okay. If we assume that x is positive, then we don't have to worry about the absolute value bars. So. That does it. It works. So same answer both ways. Is everybody comfortable with that? Awesome. Okay. Right. I'm gonna. So that one problem, I've reviewed almost everything about. Well, not everything. We didn't review a mixing problem or Newton's law of cooling, or that, but certainly in terms of the integration techniques and in terms of the how to solve a Bernoulli, a homogeneous, and a linear differential equation, we just kind of reviewed all of it. Does it seem okay? Does it feel like you could do those kind of problems? Sometimes the hardest part is just identifying the equation. Try not to get too freaked out. Some people are really, they do a great job of studying, they work really hard, and they know the material really well. And then they just get in too big of a hurry on the test because they're all freaking out. You're going to have plenty of time because I'm not going to rush you out. It's basically, you're going to have the whole class period to work on this thing and extra time if you need it. It's going to be much more time to work on it than you actually need to take the test. So if you start trying to solve it one way, it turns out you thought it was Bernoulli, but then somehow it's not working out. Maybe it wasn't Bernoulli. Maybe you should go back and double check. Am I sure I did the algebra right? Am I sure it's the right form for Bernoulli? Or is there something else that it could be? I'm not going to be trying to like trick you into, you know, thinking that it's one thing over another, but on the other hand, I do expect you to do that crucial step of identifying the equations. So, okay, so that is that. Okay, so I'm going to go on to some of the linear algebra stuff now. So these are not in the same order as in the review packet, but that's okay, because I just want to make sure I cover a lot of different things. So here's number 2. This one will be quick. Just says write the solution set, so we're changing gears completely, to the equation. Write the solution set to the equation x1 minus 4x2 plus x3 minus 5x4 equals 0. So in other words, we would like to, this is a linear equation. It's a little tricky because it's not really a full system. It's just one equation. But you guys remember, what are my 3 choices for how many solutions there will be to a given linear system?
No solutions, one solution, and something like
That's it. So there's either 0 solutions, 1 solution, or infinitely many solutions. And how do we go about trying to sort out which of those is the right number of solutions? Say again? Right, so we need to have a matrix here, right? So, you know, even though there's only one equation, you can still put it into a matrix. And that's exactly what I would recommend that you do. We're going to try and get a row echelon form by putting this thing into a matrix. So it's only got one row. It's kind of a silly little matrix here. But that would be, would everybody agree that that would be the form of this matrix? Remember that the columns of the matrix, we could call this A sharp. This is like the augmented matrix for the system. The columns of that matrix correspond to the unknowns, right? So once we've written down the augmented matrix for the linear system, which everybody definitely should be able to do, then what's the next thing we need to do? Okay, normally the next step would be do EROs to get it into row echelon form, but this one, guys, is already in row echelon form. This is a really pretty easy problem because it's already kind of done for it. The nasty part is taken care of for it. It's already in row echelon form. So you see where your pivot is. Remember that any variable that is not pivoted is called what kind of variable? A free variable, exactly. So we have actually 3 free variables here. So I could write them down. Usually I like to use letters like T, so I'll call x4, I'm going to call that T. x3 is, I'll call that one S, and x2, I'll call that one R. And then, of course, I can solve for what x1 is, but this is also very easy. x1 just becomes, you can just go back to here if you want to. First equation, because you haven't even done anything with it, and just move everything to the other side. So it would be 4r minus s plus 5t. Does that make sense? Okay, so this is a fast problem. Now what would I do next? I've written down x1, x2, x3, x4. Would that be all I would have to write down? Just read the question, right? I'm asking to write down the solution set. That's the thing where you use the squiggly braces and write down the final answer. So that the solution, this would be the set, so we use our little squiggly braces, and then what would be, how would we write this? We make the list, and there are 4 unknowns, so there's going to be 4 slots in this list. Now, did you guys notice what I did? I put the x4 on the bottom here. I have seen people do this before where they solve the problem like this. They say, okay, x4 equals t, and x3 equals s, and x2 equals r, and x1 equals whatever it is. And then I've seen people actually make the mistake of just going down the list like this and not having them in the right order, and you don't want to make that mistake. So I actually tried to write them in this order on purpose. I make it look so easy, but if you don't think about it and you write them in the wrong order, then you could end up putting down the wrong answer. So I just like to have that clear. So we have 4r minus s plus 5t, comma, r, comma, s, comma, t, and then my colon, remember, such that is what that means. R, comma, s, comma, t is an element of the real number set R. So that would be my solutions. Does this make sense? Yeah, Michelle?
On the homework, I never changed like x2, x3 to some other.
You just used x2, x3, x4?
Yeah,
Yeah, that's actually okay. So you could just leave them as what they are, and then the first entry would have just been 4x2 minus x3 plus 5x4. Yeah, that's okay. I like to do the change just to remind myself that, oh, these are free variables and I'm introducing them right now for my solution. But in theory, you could. The other reason I like to change the variables is because what if somebody decides instead of solving for x1, I'm going to solve for x2 instead. So x2 would be like x1 plus x3 minus 5x4 all over 4. That would actually also be okay, but now you're not using a systematic approach anymore to saying which variable you need to be solving for. You get into this trouble of not getting into the habit of doing the problems the same way when that comes up, and so I prefer to kind of get into a rhythm of doing it this way every time. But mathematically, you don't have to change these letters. Okay, make sense? Okay, so that was just a really easy example of how to work with these linear systems. We didn't even have to do any EROs. Either way, so another thing about my tests is, if I give you 1 inch of space to solve a problem, right? That's almost like giving you a hint. Like, this problem can be done without having to fill a whole bunch of paper. I don't like to make people go off on a whole bunch of extra scratch work and then attach their work. I try to give enough room. So if I leave you so this problem I might not give you that much space because there's really not that much here, then that's kind of a clue that it's not supposed to be that bad to solve. Okay, let's try another one. This time we might have to do a little bit more work. So this is number 3. So consider the system. We'll write down a linear system here. So x1 minus ax2 equals 3, and 2x1 plus x2 equals 6, and negative 3x1 plus the quantity a plus b times x2 is equal to 1. So notice that there's an a and a b in there. Those are going to be like constants. So you've done a problem like this or two on the homework already, but I just want to practice it again because I know that I've seen people struggle with this before. So it just says determine values of a and b such that the system has, so for the first part, let's just say 0 solutions. And then the second part, 1 solution. And then the third part, infinitely many solutions. Okay. So what would you suggest that I do first? Exactly, let's put it into a matrix, I like that idea. So for the solution, we're gonna have 1,